Welcome to Galactic Secrets, the channel where curiosity meets the cosmos, and we explore the mysteries of the universe one discovery at a time. Today, we are embarking on an extraordinary journey to two of the most fascinating and mysterious moons in our solar system, Europa, orbiting Jupiter, and Enceladus, orbiting Saturn. At first glance, these icy worlds may seem frozen and lifeless, but beneath their thick, frozen crusts lie hidden oceans. Oceans that may rival Earth's in size and complexity, and oceans that could potentially harbor alien life waiting to be discovered. Before we dive in, I want to thank you for being part of our community here on YouTube. Your curiosity, your passion for the cosmos, and your desire to understand the unknown are what make this channel possible. By being part of Galactic Secrets, you are joining a community of explorers, thinkers, and dreamers, all seeking answers to some of humanity's most profound questions. Are we alone? Could life exist in places we have barely begun to imagine? What secrets are hidden beneath the surfaces of distant worlds? If you are fascinated by alien life, hidden worlds, and cosmic mysteries, subscribe to Galactic Secrets, hit the notification bell so you never miss an episode, and like this video. Your support allows us to continue producing high-quality, immersive content that uncovers the universe's greatest secrets. Be sure to share this video with your friends, family, and fellow cosmologists, and check out our other videos, covering alien worlds, UFO phenomena, mysterious cosmic events, and the most incredible scientific discoveries that continue to challenge our understanding of the universe. Today, we are not just looking at ice and rock, we are peering beneath kilometers of frozen crust into oceans hidden in eternal darkness, exploring the potential habitats for life on Europa and Enceladus. These moons are not just celestial objects, they are potential incubators of life, natural laboratories that have persisted for billions of years, shielded from harsh space conditions. Together, we will explore what makes these worlds extraordinary, the scientific discoveries that have revealed their secrets, and the missions that may finally answer the ultimate question: are we alone in the universe? 1. Why Europa and Enceladus are changing the search for life for decades. Astrobiologists believe that life could only exist within a star's habitable zone, the narrow region where surface temperatures allow liquid water. This idea assumed sunlight was essential for life, but Europa and Enceladus challenge this assumption. Both moons demonstrate that life may not require sunlight at all. Instead, internal heating mechanisms, such as tidal flexing caused by gravitational interactions, radioactive decay within the moon's cores, and chemical interactions between water and rock, can create conditions suitable for life. Europa and Enceladus suggest that the universe may be far more hospitable than previously imagined. Life may exist in hidden oceans beneath frozen surfaces across the galaxy, in places that were once considered completely inhospitable. This expands the search for life to moons, dwarf planets, and even exoplanets with subsurface oceans. The concept of a habitable zone is evolving. Instead of being restricted to planets orbiting stars at just the right distance, life may exist in a wider range of environments where energy, water, and chemical nutrients are available. These moons also demonstrate the importance of chemical energy in sustaining life. On Earth, hydrothermal vents and chemical gradients in the deep ocean support ecosystems without sunlight, relying instead on chemosynthesis. Europa and Enceladus may host similar processes, potentially creating ecosystems powered entirely by chemistry and internal heat. This revelation dramatically expands the possibilities for life beyond Earth, inspiring new missions, new scientific methods, and new hypotheses about life in the cosmos. 2. Europa. A frozen moon with a global ocean. Europa, slightly smaller than the Moon, has long fascinated scientists with its icy exterior and suspected subsurface ocean. Its ice shell ranges from 10 to 30 kilometers thick, beneath which lies a global ocean containing more water than all of Earth's oceans combined. Europa's ocean is kept from freezing solid by tidal heating, produced by Jupiter's immense gravitational pull stretching and compressing the Moon. The constant flexing generates internal friction and heat, maintaining liquid water beneath the ice. Europa's surface is marked by linear ridges, long cracks, and chaotic terrain, suggesting that the ocean below may interact with the ice in specific regions. Some areas of the ice shell may be only a few kilometers thick, allowing for chemical exchanges between the ocean and the surface. These processes could deliver nutrients, salts, and energy to the upper layers of the ice, creating habitable niches for life. In addition, Europa's ocean may circulate in currents similar to Earth's oceans, distributing heat and nutrients across the Moon. The combination of liquid water, internal heat, and chemical interaction makes Europa one of the most promising locations to search for extraterrestrial life. Studying this moon can also provide valuable insights into the potential for life in icy exoplanets beyond our solar system. 3. The clues on Europa's surface. Europa's ice is more than just a frozen shell, it's a map pointing toward a dynamic subsurface ocean. Its surface features reveal clues about the interactions between the ocean, the ice, and the moon's interior. Long dark streaks and bands of disrupted ice suggest that liquid water may occasionally reach the surface, while chaotic terrains indicate regions of geologic activity and ice recycling. Some areas may allow chemical exchanges, where minerals, salts, and organic molecules from the ocean mix with surface ice. These interactions could supply energy and nutrients that sustain life. Europa's surface features also hint at tidal flexing, ocean circulation, and potential hydrothermal activity, offering indirect evidence of habitable zones beneath the ice. Every crack and ridge provides scientists with vital information about the moon's internal processes, chemical composition, and the potential for life. 4. Enceladus. The moon spraying its ocean into space. Enceladus, at just 504 kilometers in diameter, is much smaller than Europa but equally compelling. NASA's Cassini mission revealed active geysers at its south pole, ejecting water vapor, ice grains, salts, and organic compounds into space. These plumes provide direct evidence of a liquid subsurface ocean, making Enceladus one of the most accessible moons to study for signs of life. The plumes indicate hydrothermal activity, where water interacts with the rocky core, producing chemical energy that could support microbial life. Unlike Europa, Enceladus ejects ocean material into space, allowing scientists to analyze its composition remotely, without drilling through kilometers of ice. Salts, silica particles, and organic compounds found in the plumes suggest that the ocean is chemically active and may harbor the ingredients necessary for life. The ongoing activity on Enceladus implies a geologically young and dynamic environment, where chemical nutrients and energy could sustain ecosystems beneath the ice. This moon offers a unique opportunity to study alien oceans directly, opening new pathways to understanding life beyond Earth. 5. Hydrothermal vents and potential energy sources. Water alone is not enough, life also requires energy sources. On Earth, hydrothermal vents in the deep oceans sustain rich ecosystems independent of sunlight, powered instead by chemical energy. Scientists hypothesize that Europa and Enceladus may host similar hydrothermal systems beneath their icy crusts. In Enceladus's ocean, water interacting with a rocky core may produce hydrogen gas, methane, and other compounds usable by microbes. On Europa, tidal heating and chemical interactions could create similar energy gradients. These hydrothermal systems could sustain life entirely independent of sunlight, creating self-contained ecosystems in environments previously considered too extreme. The presence of these energy sources dramatically increases the likelihood that microbial life could exist in these hidden oceans. 6. What kind of life could exist? If life exists beneath Europa's or Enceladus's ice, it would likely be microbial or extremophile, capable of surviving extreme pressures, freezing temperatures, and complete darkness. These organisms may rely on chemosynthesis, deriving energy from chemical interactions instead of sunlight. Even the simplest life forms would constitute a monumental scientific discovery, proving that life can emerge in environments radically different from Earth's. Some scientists speculate that alien life in these oceans may resemble Earth's extremophiles, while others suggest entirely novel biochemistries could exist, including life that does not rely on carbon or oxygen. Discovering any form of life would reshape biology, astrobiology, and our understanding of the universality of life. 7. Missions searching for life. Exploration of Europa and Enceladus has been one of the greatest scientific priorities of the 21st century. NASA's Europa Clipper mission, set to launch in the 2020s, aims to conduct detailed reconnaissance of Europa's ice shell, map its subsurface ocean using ice-penetrating radar, and analyze surface chemistry with advanced spectrometers. The spacecraft will make dozens of flybys, collecting high-resolution images and data to identify potential habitats for life and areas where the ice is thin enough to allow chemical exchanges with the ocean below. For Enceladus, future missions aim to fly through its active plumes, sampling water vapor, ice particles, salts, and organic compounds directly. This approach allows scientists to analyze the chemical makeup of the subsurface ocean without drilling through kilometers of ice. Instruments can detect complex organic molecules, amino acids, and potential biosignatures, helping answer the age-old question: could life exist in these alien oceans? The success of these missions could revolutionize astrobiology. Europa Clipper will also study the thickness and dynamics of the ice shell, the salinity and composition of the ocean, and potential hydrothermal activity. Future Enceladus missions may include orbiters, flybys, and possibly landers that could directly search for signs of microbial life. Together, these missions mark the beginning of an era where humanity moves from speculation to observation, where hidden oceans and alien ecosystems become tangible objects of study. 8. What finding life would mean for humanity. Discovering life beneath the ice of Europa or Enceladus would be one of the most profound scientific achievements in history. It would confirm that life is not unique to Earth and that the universe may be far more biologically diverse than we ever imagined. Life in these oceans would prove that organisms can survive in extreme conditions, completely isolated from sunlight, adapting to high pressures, freezing temperatures, and total darkness. The implications extend beyond science. Philosophically, it would challenge humanity's understanding of our place in the cosmos. Culturally, it would inspire new stories, new myths, and a renewed sense of connection to the universe. Technologically, the discoveries would stimulate innovations in space exploration, robotics, chemistry, and life detection instruments. Finding life, even microbial, would indicate that life is likely common throughout the galaxy, existing wherever water, energy, and chemical nutrients converge. It would also guide the search for life on exoplanets, helping scientists identify which distant worlds may harbor life based on lessons learned from Europa and Enceladus. Humanity would finally have concrete evidence that we are part of a universe alive with potential, and that life can thrive in places once thought impossible. 9. Silent oceans waiting to be discovered beneath kilometers of ice. In darkness unbroken for billions of years, Europa and Enceladus harbor oceans isolated from the surface and the sun. These silent, hidden worlds have remained untouched by cosmic radiation, meteor impacts, and surface extremes. Their isolation means they may contain ecosystems that have persisted for geological timescales, completely independent from Earth-like conditions. These oceans remind us that the universe often conceals its most extraordinary secrets, waiting for human curiosity to uncover them. Exploration of these moons challenges us to think beyond conventional notions of habitability, to imagine life thriving in environments vastly different from our own, and to ask new questions about where life could exist elsewhere in the galaxy. Every fissure, every plume, every trace of chemical activity represents a clue, a piece of a puzzle that could reveal entire ecosystems hidden in the darkness. Europa and Enceladus teach us patience, resilience, and the power of observation, lessons humanity will need as we continue our search for alien life. 10. The beginning of a new era. With Europa Clipper and future Enceladus missions on the horizon, humanity is entering a new era of exploration. The possibility of detecting life in alien oceans is no longer science fiction, it is becoming a tangible scientific reality. Europa and Enceladus could be the first moons in our solar system where we confirm the existence of extraterrestrial life, raising questions about how many other hidden oceans exist across the galaxy. These moons are not just frozen rocks, they are gateways to understanding life across the cosmos. By studying them, we gain insight into how life emerges, survives, and adapts in extreme environments. Their oceans could hold life forms that have evolved independently from Earth, offering a glimpse into the diversity and resilience of life in the universe. This exploration marks the beginning of a new scientific revolution, where we are no longer constrained to our own planet but can begin to understand the potential of life in the universe. Europa and Enceladus remind us that exploration is a journey of curiosity, imagination, and courage. The secrets of these icy moons may forever change our understanding of biology, evolution, and humanity's place among the stars. Call to action. If you enjoyed this journey into the hidden oceans of Europa and Enceladus, subscribe to Galactic Secrets for more videos exploring alien worlds, UFOs, cosmic mysteries, and the frontiers of space science. Hit the notification bell so you never miss an episode, and like this video to support our channel. Share this video with your friends, family, and fellow space enthusiasts, and explore our full catalog of videos to continue uncovering the universe's most astonishing secrets. Together, we can discover the unknown, push the boundaries of human knowledge, and imagine a universe teeming with life.